So we're coming in a few minutes late, but that's okay.
You're driving this meeting, I assume. Or I'm new it, but I'm not sure exactly.
Let's see, maybe a little bit. So, okay, here's a paper for taking live minutes. Well, I don't know. I don't want, because you guys already started, so I don't want to like intervene too much. But I would be curious to see a. There's, I guess, there was the 3 proposals, right? And it seems like the most interesting thing is to discuss.
I think the differences between 1 and 2 are sufficiently minor that we can just not worry about them for now.
So
it's really an edge case on whether you're allowed, whether you can long jump across ffi-unwind and whether this is guaranteed to always work. But I don't think anyone's really going to do that in practice. If you're using ffi-unwind, you're always going to be calling code that throws exceptions rather than long jump.
In particular, the very specific claim that was stated at the start before the video was recording started was that proposal 2 is strictly better than proposal 1, and we spent a little time discussing the details there.
Yeah,
so
basically,
maybe we can defer discussing the details between those 2.
Yeah. The more interesting question is the difference between proposal 2 and proposal 3. With proposal 2, extern C means no unwind. And if you try to unwind out of an extern C, you get UB. However, long jump out of an extern C. So long jump out of an extern C always works under all proposals as long as you have no destructors on the frame that is skipped.
Yeah.
So with proposal 2, we add a separate ffi-unwind ABI, which says this may unwind. And if you compile with panic equals abort, ffi-unwind will generate a small wrapper function, which will catch the exception and abort. So this ensures that if an exception somehow escapes into Rust code compiles with panic equals abort, we get an abort instead of UB.
Right, but we would not abort for a forced unwind.
And we have to do that because of soundness.
I mean, you could argue that all proposals are sound, and it's the user's fault for not catching exceptions at the source. Since this is all FFI and.
If you.
Oh yeah. Oh yes. Also, you're right. Sorry. If a Rust.
Right.
Panic. Right. So this is the first line of the table in the blog post. If a Rust panic reaches an extern C boundary, then we turn it into an abort with panic equals unwind.
Right. Yeah. All proposals are sound, at least in that respect. If you remove no unwind, then it's sound. And if you abort,
yeah,
then it's also sound.
Well.
So I'll give a quick overview of proposal 3. Basically, proposal 3 works. The idea of proposal 3 is that we keep things simple. We just keep extern C. When you have panic equals unwind, you're allowed to unwind through it. When you have panic equals abort, you're not allowed to unwind through it. And it's your responsibility as the user to make sure that if you call code that will throw exceptions back to you, you must compile with panic equals unwind. This is basically the same thing as if you write C code that calls C++ that may throw an exception, you need to use -f exceptions. Otherwise, you have UB.
Did you do any size comparisons on Fuchsia and whatnot?
We didn't, but they're not really relevant because,
They are?
well, in all of these proposals, if you use extern C, we basically don't do anything. If you use panic equals abort and extern C, we don't add unwinding tables or machinery. There were some earlier drafts where we were considering what would it be like if you did have like a shim to intercept unwinding and things like that. And in particular, the question was, because if we were, one of the advantages to having C unwind is that you can only insert, is that you have a narrower set of places to insert shims like that. Right? So we were considering, well, what if we put the shims at all C sites? How bad would that be? And I did make a version of the compiler that did that, but we didn't end up going with that proposal. I'm trying to remember all the reasons why, but that would not be this, that would be a different version. And this, like if we say that it's UB, then you don't need to have a shim. So there's really no overhead. You can still add a shim as a debug mode or something to help people catch it in practice. But in release, at least, there would be none.
I think the only size difference would be that with proposal 2, you could optimize away some landing pads if LVM thinks they're unreachable. Because we mark extern C as no unwind.
So that would also be possible if proposal 3 was extended with a no unwind attribute, right?
Yes.
Which I think is mentioned in the blog post.
No, it's not mentioned in the blog post, but we did discuss it in our
It's
meeting.
Yeah, it's in the HackMD notes.
Oh, yeah, that's where I saw it.
So wait, let me make sure I understand what you're saying. You're saying if you have panic equals unwind,
yeah,
and you call some C functions, and we're saying that they then nowadays they might have a no unwind attribute that would allow us to optimize away some landing pads potentially, but in proposal 3, for example, they wouldn't have that attribute unless some other mechanism were added, and therefore we would keep the landing pads. Is that right?
Yeah.
Okay, that seems right. But I do also think that, like for Fuchsia, for example, the people who care the most about that are compiling with panic equals abort in any case. So they don't have landing pads in the first place to be optimized away.
So in the last meeting, we went into a bit of discussion of what would it take. So if you open up the HackMD, you can see some examples. There's a code block with proposal 3, code block with proposal 2. With proposal 3, if you call, so with proposal 3, we added some attributes. These are not part of the proposal, just an exploration of what we might want to add in the future. So there's a no unwind attribute, which is basically C++ no except, and then abort if panic equals abort, which basically is this equivalent to the wrapper shim we have in proposal 2. So you can see basically if you have, also proposal 2 has a slight advantage in that it allows us to mark function pointers as not unwinding. And to get that in proposal 3, you'd have to add attributes on types, which is not possible yet.
No, not very difficult to implement syntactically.
Yeah.
But you have to reroute it into
Yes, and then the no unwind function, the function pointer with no unwind attribute isn't exactly the same type as a normal function pointer. So it's a whole other mess.
But this is all like
Hypothetical.
I mean,
but
like you're saying, if we added attributes to functions to declare them as not throwing exceptions, then we could do some optimizations, but they wouldn't propagate through function pointers unless we extended it to the type system.
yes.
Okay, right.
You can also reason about, well, this function cannot possibly unwind, so I can use that in like reasoning for assignments, not just for optimizations.
Yes.
Possibly.
So the main difference is if you just have an external C. So the conclusion we reach is that proposal 2 is better if the user gets his annotations right. That is, if the user properly marks functions that actually do throw an exception as C-unwind, then everything works fine. Because you get UB if an external C under proposal 2, you get UB if an external C function unwinds.
Most likely you get an abort.
It depends on the platform. I think on Linux you're probably going to get an abort because, well, no, actually with Panicles, no. What's most likely to happen is that your code will continue unwinding, but your destructors won't get run, which is terribly unsound.
Can you spell that out a bit more? What are you
so,
comparing against which thing here? Saying proposal 2 is better than what, first of all?
So proposal 2 is better if the user has properly annotated all of the functions that might throw a foreign exception as C-unwind.
You're saying proposal 2 is better than having like a C-unwind, a separate C-unwind ABI is better than just a unified C ABI. And yeah, I might, okay.
Because so under proposal 3, proposal 3 is simpler because we just have a single ABI, the user, it's easier for users to just decide, okay, my C++ code that I'm calling might throw an exception, so I just need to make sure to compile with pan equals unwind, and it will just work. I don't need to worry about annotating my FFI calls correctly.
I was hoping we could I'm feeling a little confused. Can we make better a little more precise? Like a C-unwind ABI is better.
Less error prone, I'd say.
You think it's less error prone to have 2 ABIs or 1?
So I feel it's less error prone. If the user makes a mistake and accidentally calls a function that does throw an exception, but calls it via extern C, they will get UB under proposal 2, but not under proposal 3.
Under proposal 2, if you have an extern C function that you are exporting to C, and then C calls that one, then we have to abort.
No. So I'm talking about you calling C++ code and that C++ code throwing an exception.
Into you.
Yeah.
So we're talking about imports, not exports.
Yes.
It seems like we're saying,
Oh,
I mean, we're basically talking about the,
So this is a foreign exception, then a foreign C++ exception, not a.
I think to recall in the previous meeting, we discussed some cases where there was surprising foreign exceptions as well, or like sources of this happening, like C++
If
structures.
C++ code runs out of memory, it throws a bad alloc exception, which tends to come as a surprise because, so in this particular Rust bug, we had the C++ exceptions unwinding all the way through Rust code and causing a seg fault because catch unwind couldn't handle foreign exceptions properly. This is fixed now. But the point is, you can sometimes get surprise exceptions where you don't expect them.
And by the way, Ralph raised the point around the soundness concerns around catch and wind and like take mutes. Seems no one responded to that.
I did respond to that. I think it's possible to change catch and wind to actually catch foreign exceptions.
Can we say that in more detail? What was Ralph's point?
Let me link it.
Basically, code may rely on catch and wind to actually catch exceptions, to do some fix up, and then rethrow that exception. It's the same thing you do with a drop guard, but it's done with catch and wind instead.
Okay. And
at the moment, catch and wind ignores foreign exceptions. It just lets them unwind through. But this is relatively easy to fix.
And how does that relate to proposal 1?
It doesn't. It doesn't. It's an unrelated issue.
Okay.
Yeah, it's kind of an orthogonal concern. Okay. It seems like to me like the heart of this matter is if we adopt a unified ABI, then in some sense it's easier to tell people what to do. On the other hand, the consequences of failure, I don't know. You have to make sure your panic equals unwind and panic abort things are lining up with the no exceptions that you're expecting if you're linking against foreign code. And what are the other, like, we're giving up some kind of optimization opportunity in the case of panic unwind, although I consider that it seems pretty minor because
it's probably minor.
Will still have landing pads. It's only around these narrow areas where you're only calling for.
Yeah. We lose the ability. Yeah, it's
I think the main downside is like C panic. It seems like there's a reasonable concern that if you do C panic equals abort, you can have some libraries that are like, due to their use of foreign exceptions, are kind of incompatible with C panic equals abort. And we just won't know, essentially. Right.
Yes, because this is the panic mode is not reported in any attributes. I think it's not available in CFG.
Right. So like they invoke C++ code, for example, that will throw an exception. And you compile it with C panic equals abort. That C++ code throws the exception. Instead of catching it, we now have UB. And so we really don't want C code or C++ code and panic equals abort unless the C++ code is compiled with no exceptions, essentially.
Or you've written the proper catch clauses around all your entry points.
Yeah.
And I know I've made this point before, but just like coming from the world of integrating C and C++ and Rust in embedded situations and whatnot, like that is exactly the behavior that I would expect, is that I would need to make sure that my Rust compiler options line up with my C and C++ compiler options. So it may feel like a bunch of rules in special cases, but I think it'll line up with a lot of people's expectations.
Right, and when we say compile with F no exceptions, what we really mean is don't throw exceptions. Like, it's also, I'm sure, UB and C++ land to compile with F no exceptions and then throw an exception. So
yeah, if you're lucky, the compiler will throw an error, but not guaranteed.
But the upside then is that it's just, we haven't gone at all into like some of the annoying, well, I don't remember how many corner cases there were, I guess. The main thing I was thinking of, I guess we kind of sidestepped the corner cases around like calling read and having pthread. Certain platforms, when a read is canceled, they'll throw an exception. But I guess those are all forced unwind cases. Is that right?
Yes, basically, the consensus with forced unwind is that, well, okay, there's no consensus, but with proposal 3, forced unwinds will just work if you compile with panic equals unwind. Otherwise, they will only work if you have no destructors.
Right.
It's a mess, and you really shouldn't be using pthread cancel with Rust code.
Yeah, or arguably at all, but yeah.
Or that, yes.
But I don't know. I mean, I think it's okay that it works if you don't have destructors. Like, that's, some people may need to use it for specialized reasons, and or if you use panic equals unwind, I guess.
I don't think there's much else to say, really. There are, the advantage of proposal 2 is that if you get your external annotations right, then your code works whether it's compiled with pan equals unwind or pan equals abort.
I think that's a very good advantage, or an important advantage. Ideally, switching between compiler flags shouldn't suddenly make your code unsound. Another advantage to proposal 2 is that the area, like the amount of functions that we have to make the unwinding behavior defined for, or the strategy is smaller, because we have cored enough the functions to a special C-unwind API. So there are fewer functions that would be affected if we switch things for the C one. And I expect that one will continue to be used the most.
However, again, the downside here is that if you get a surprise exception from C++ code, like we had in that issue where C++ code runs out of memory, throws a bad alloc exception that honestly nobody was expecting, it unwinds into your Rust code and you've got UB. Arguably, it's a program error because you should have caught the exception or something, but it's the sort of thing that could happen.
Central, I didn't quite hear what you said before. You're just saying that there's a space advantage to not having all the functions potentially unwind, or was there something else?
So presumably, if we have a C-unwind ABI, then we have to sort of define that one, the unwinding behavior for that one to be the native one. And if we have C-unwind, then the C-unwind ABI, which I assume most functions will still use, has more freedom to change the strategy for unwinding.
What has more freedom to change the strategy? The C ABI?
So I think what Central is saying is that if Rust decides to use a different unwinding implementation, we only need to add translation shims on C unwind entry points, not all
Right.
external C entry points.
I see.
Right.
Yeah.
Yes. And that's a fewer. The amount of functions that use C unwind would. My guess is they would be fewer.
Okay, that's interesting.
So it would impact fewer functions and less code.
Yeah, that's an interesting twist.
So right now, I'm favoring going with proposal 1/2.
I'm going to try to collect the things. I don't know what I think, but I think that's an interesting point. So like the other, I mean, okay. I'm just going to skim our notes from before. Kyle, do you remember we had, when we came up with this like proposal 1, 2, 3, we had like a long, was it HackMD or something?
It was a paper. Let me see if I can find it.
Oh, where I got the table from, or yeah. Yes.
I think it's this one. Okay, found it.
It's a bit confusing because I think proposal 1 and 2 might have gotten switched from how we were.
They have, yes.
Yeah.
So I think proposal 1 is option 1C.
Okay.
2 is option 1 from the original version.
Yeah. Thanks for simplifying the table, by the way. That was very hard to understand before.
The thing I thought, okay, one of the things we did before was to talk over some of the scenarios like long jump error recovery, and how would you handle each one? C++ exceptions that propagate.
So long jump, the idea of long jump is that you can long jump over extern C just fine under all proposals. The only requirement is that there must be no destructors in the frame that you're skipping. Otherwise, it's UB.
So if you're
How
invoking
often
a
is-
C library that uses long jump,
Lua, some Lua library.
My impression is that long jump is mostly about legacy code. Is that
Mostly about, sorry?
legacy code?
It's used quite extensively in Lua, and you often have callbacks that get long jumped over.
Right.
But for example, the same rule applies to pthread exit. If you call pthread exit, you can only do that if there are no active destructors on the frame, on the thread stack that you're exiting.
And that's only true on,
That's
you
true.
said
That's
Linux.
true. That's true everywhere, because you're freeing the stack without running these structures. So it's as if you long jumped over the whole stack.
Got it. The
Last
difference
time
is only one thing has it as a unwind, but okay.
Yeah.
Understand.
Last time I used set jump and long jump was in like operating systems course where I was implementing a shard. Felt incredibly strange. Hacky.
Yes, we're really supporting it because some C libraries depend on it.
Right.
I think I also think Ruby does. It's not so uncommon. So the other thing would be, if I don't know that anyone's ever asked for this, but C++ exceptions propagating, and we kind of already covered this, but we said you would use
C-unwind.
let's see, proposals 1 and 2. You would use C-unwind ABI to signal that.
Whether it's a C++ exception unwinding through your code, or if you want to let a Rust panic leak out into C++ code.
In this case you're currently on, that you're describing, are you including the case where allocation from C++ throws an exception, or are we treating that like a separate case where like that's a very rare thing that you should be checking like via separate means and not relying on that exception mechanism?
That is, well, it is included because C++, the bad alloc exception is just a normal C++ exception. So from that point of view, you really, ideally, you should be handling it before it reaches your Rust code.
Right. Well, I see. The C++ code should be handling it first. Okay.
Translate it into an error code or something, or just use C-unwind and let it unwind through the Rust code as well.
Yeah, I guess the point of my question is, I've been in other software shops where their approach is to say, well, it's such a nightmare to handle that they said the official policy was you should be monitoring your memory usage via separate means and like avoiding calling allocating functions rather than ever have this arise. So I was sort of curious whether this was that scenario, but it sounds like you're saying, no, we should treat it as something that's may happen, but rather it's the C++ jobs to either handle it within the foreign code, or you should use the C-unwind ABI for those cases. And if you use the C ABI, you get what you pay for. Is that sort of what I'm hearing?
Yes. If you use C-unwind, and if you're compiling with pan equals abort, this will automatically get caught and turned into an abort on the Rust side.
One thing I'm hoping or sort of seeing is that people will write proc macros to handle these cases better. So I've seen some people implementing crates for shims and stuff.
What kind of proc macros do you have in mind?
So handling mainly around serialization between ffi and whatnot, but handling panics and stuff via proc macros. I've sort of
and turning them into error codes.
Yeah, I've sort of seen that happen. I think what a friend of mine wrote crates, and I don't remember the name right now.
I think I've seen it before. So c-unwind could be an alternative to that, to just let it unwind through and not be our problem.
Yeah, maybe people can take advantage of ffi-unwind in some
Well,
sort of macros.
Procedural macros work on the Rust side, where they generate C++ shims to intercept the exceptions.
Right.
I think it's mostly for catching Rust panics and turning them into error codes before passing them back to C or C++.
Okay. So that would be the other thing I'd like to do before we leave. Maybe it's worth talking over. I don't know if there are any other scenarios that are relevant. Well, Adam, the scenario you're thinking about, maybe we should write that one out because I feel like.
Yeah, so just as a refresher, we are generating native code from WebAssembly, and then we are hosting WebAssembly modules instantiated with that code in a runtime that's implemented in Rust. And the nature of a WebAssembly execution is that you use WebAssembly import functions to do anything useful. The WebAssembly code itself is just purely computational. And so we have Rust on sort of the outside of the program. It's like the entry point for the executable, setting up the instance and whatnot, and then running the WebAssembly. But then the WebAssembly can call back into Rust for these import functions to do things like write to a file or open an HTTP connection, things like that. And the issue that we have is wanting to be able to have the Rust code that implements those import functions be able to panic, unwind through our generated native code, and come out the other side and be caught by the like entry point side of our runtime setup. For the purposes of, or like for the narrowly focused purposes of our application, I think any of these proposals would be suitable for us because we have, you know, complete control over the ABI string used for the WebAssembly functions that we're loading and running. I'm trying to think if there are any other wrinkles. We mentioned that proposal 3 had some interactions with function pointers because we don't have attribute syntax for function pointers. And while it would be a big deal for us if an attribute was required to mark a function as unwind, it doesn't appear that that is part of any of these proposals at that point. At this point, it seems like the attribute is only on the table to mark something no unwind, which would be fine for us, even though we are dependent on using function pointers.
Wait, I assumed in proposal 1 and 2 that function pointers are, well, it doesn't matter if you use the C ABI. It doesn't matter if it's a function pointer or not a function pointer.
That's right. My read on it is that attributes are completely irrelevant to proposals 1 and 2. I bring up function pointers because it was part of the discussion around proposal 3 and the possibility of having a no unwind attribute.
I think for your particular case, for proposal 2, you just use C unwind.
Yep.
For proposal 3, you just make sure to compile with panic equals unwind.
That's right.
And
so in proposal 2, you would use a C unwind function pointer.
That's right.
As it happens in your code, you don't have any desire to intercept this Rust panic. But I guess the only kind of interesting twist on that would be like if you had a C++ frame. I mean, right now the destructors would run for C++ values because we are converting to a native panic, conceptually at least. I guess there's some amount of we're defining a little bit what our panic string looks like or whatever on those platforms, or at least it's observable, let's put it that way. We can leave it a little undefined. I think that's fine. That's sort of true for all these proposals, I guess. Okay, never mind.
Yeah, and so looking forward, I don't expect we're going to have C++ frames in the mix with destructors, but the WebAssembly extensions proposal, or sorry, exceptions proposal is moving forward, and it's somewhere between likely and possible that we will want to use the native unwinding mechanism to implement that in the native code that's generated from WebAssembly. So that would basically look the same as though we were wanting our Rust panics to unwind C++ frames and run destructors, potentially.
Yep, okay. Cool. I think that about covers all the, I guess the only other conceptual scenario would be kind of C code invoking Rust, that invoke like the same situation, but the sandwich is reversed. And that's already sort of what we said about, well, what if you wanted to have C++ errors that propagate through your Rust code? That's kind of the same thing.
Yeah, and to the extent that that would be an interesting case for us, I don't think it's ever going to be the case that like we'll need to explicitly catch the foreign exception. It's more a matter of, will the foreign exception unwind and run destructors in the frames in between? Like we would definitely have like some sort of shim to translate between the foreign exception and an error code when it's finally time to clean that up.
The last thing I thought, you have only a few minutes left, so feel free to steer me differently, but I thought it might be useful to just narrow down for each of the proposals, like, what do we have to do at the different spots so that we understand this clearly?
For
like,
proposal 3, nothing.
Right. So proposal 3, we generate normal function calls. The same, basically C and Rust calls are the same modulo, other ABI differences. So in other words,
and we promise never to put no unwind on C functions, right? It's like a going forward
we put no unwind when compiling with C equals abort, panic equals aborts.
Oh, right, of course.
And we stopped doing that for panic equals unwind.
Yeah.
But this is in the compiler, not the spec. And presumably, well, we have to.
I mean, it's UB if you unwind into Rust code compiled with panic equals abort.
How does that interact with that definition for LLVM already exempts forced exceptions or something?
Sort of. Forced exceptions are,
or forced unwind or whatever it's called.
Yeah, they're a bit magic. I would not worry about forced unwind at the moment when deciding between proposals 2 and 3. In practice, like you just long jump just works as long as you don't use as long as you don't have destructors. Pre-thread exit just works as long as you have no destructors.
Right.
And this is orthogonal to the whole, and it just works whether you have pan equals unwind or pan equals abort.
Okay, so
it's orthogonal.
So for proposals 1 or 2, there are basically 3 possibilities, right? Or 4, sorry, 4 scenarios that are maybe interesting. Because sometimes we've drawn, I know, like, for example, here we had talked about
on panic equals unwind, we need to catch Rust panics and turn them into aborts.
Right. So
for that one, the third one.
The third one.
Yeah. we need to, with panic equals unwind, we can't let Rust panics escape an external C because that would be UB.
Oh, I see what you mean. Yes, okay. So with C panic equals abort, we don't have to because it already aborted.
Because panics don't exist.
Right.
We don't create exceptions for them. And invoking a C unwind, we
don't actually have to do that because it's just UB. We can if we choose, right?
Which one?
Here, like it's UB to panic through an extern C boundary.
Yeah, but you can do this with only safe code. So we have to catch it.
There is no option.
Okay.
It's unsound if we don't catch it.
Yeah.
That's the case that started all of this.
For invoking AC unwind with panic equals abort, we need to catch foreign exceptions and turn them into aborts.
So for invoking C unwind, we catch.
So only with panic equals aborts.
We catch a foreign exceptions. Basically, we catch non-forced exceptions, right?
Yeah.
And turn them into aborts. Okay. And we're going to leave it as UB if there's destructors in scope. So.
Yes. So forced exceptions have the same rules whether you use C or C unwind.
Right.
It's just you cannot have destructors.
And with invoking a C ABI function, we do
nothing.
Nothing, no matter what. We mark them as no unwind.
No unwind, yeah.
And generating the body here, we basically do nothing.
Nothing.
Okay. Okay.
Well, so C unwind, if we have a C unwind API, that's strictly more complex in terms of the specification and compiler. Sort of because the proposal, that proposal subsumes proposal 3 sort of.
I think proposal 3 is basically what's implemented right now, sort of by accident, in that we currently don't emit no unwind.
We do.
We do.
Yeah, that was part of the thing, the events leading up to the formation of the working group. Or the project group.
But anyways, proposal 3, yes, is very simple to implement.
So this concern about where you can panic, oh, I see why. Never mind. Okay.
It doesn't feel like any proposal is like proposal 1 and 2 is very complicated to implement either in terms of the amount of code and stuff.
Yeah. It's not too difficult. All right. Well, we're about out of time, but I think this
we sort of have to do it in any case because of the unwind attributes. So,
I mean, it seems clear. So introducing a C unwind ABI is more work to implement, but not a lot. I think it's not totally clear to me whether it's like more or less work for the humans who write the code. It's kind of simpler on the one side, but on the other, you've got the fact that when you switch to panic equals abort, there's like extra considerations.
My sense is that the learning curve is higher with proposals 1 and 2. Just if I'm thinking about like introducing this concept to my teammates, there will be a lot more explanation required than just like, okay, you might get more landing pads with proposal 3, but there's an attribute that might help with that later on.
So are your coworkers familiar with like LVMs normal?
No.
But
And I think in general, more people will be familiar with C++'s no except than with LLVM's no unwind. And if we introduce an attribute, it sounds like it'll be analogous to no except, probably.
Just to be totally clear too, the plan is still that there's no subtyping relation at all between the two function pointers, the two ABIs, right? They're
Right.
just not interconvertible. Okay.
Yes, but in any case, a conversion can be made, can be written as just, a wrapper function. That'll always be an implicit conversion.
Right, but that is a top level version, not subtyping.
Not coercion, conversion. Like
one other thing I might mention that I think seems
What is the difference? What is the distinction between coercion and conversion? Is it as versus implicit?
I think that
I meant it's not a type relationship at all. Just like you can write a function that calls a function with a different ABI. And if you want to interoperate, you just do it via function calls rather than types. Does that make any sense?
just right.
users can work around the lack of a coercion by inserting.
Oh, you write an
Right.
explicit wrapper. Oh,
Yeah, the compiler isn't
Oh,
doing any
so-
of this for you.
oh,
Yeah.
the compiler could insert a coercion and introduce a shim automatically, and that wouldn't be subtyping. It would just be at the top level, and we have a bunch of versions like that in the compiler for including for function pointers.
But this would all be hypothetical future work, not part of the initial deployment, I assume.
Right. Oh, I wanted to bring up one other thing, which was
Doesn't matter.
in terms of the, it's kind of orthogonal to which one we do, but we could consider that in debug mode, we might add more shims and things. So like for panic equals abort, there are places where we introduce UB, and in debug mode, we might consider.
I think that makes sense. I mean, you can, depending on how much it affects compile times and whatnot, you can optimize for the best user experience there. But I mean, we don't provide guarantees, so we can tweak things as we go. So,
I'm not sure where exactly that would apply. I guess for proposal 3, it would be pretty clear.
If you are under, so you could add catch clauses to every single function under panic equals abort, just in case an exception does happen to unwind out of FFI code and catch it there.
That's what I
So
mean.
essentially, you're just inserting abort shims on every extern-C.
Right. And I'd like to, I don't know, yeah, we have to see it. It's an idea, something we could do, kind of like we do for integer overflow. It's slightly different, but since we have a defined behavior in that case.
right. I think in this case, unlike in integer overflow, we would not define the behavior, but like provide some shims anyways, just to be nice in debug mode.
All right. So I think the biggest thing is, yeah, you already said, but using C-unwind lets us identify Rust libraries that are sort of expecting unwinding, and handle it more gracefully but it requires people to annotate correctly, and that's something they have to learn, and that's something they might misuse. Okay. All right, I have to go. This was cool. We should figure out how we're gonna, I think we should ponder and I guess try to reach a decision in the next week or two, because it's time to be done with this discussion. But
We have Seal Trust next week, so I assume you didn't mean design meeting.
no. I'd rather not try to reach a decision in the meeting anyway. I find that a little stressful.
Do we want to Do we want to try to take a quick straw poll asynchronously, like put a link to some polling thing in Zulip and just see where everyone stands?
That seems okay. Yeah.
Okay.
I don't actually know.
Do we have a tracking issue or something for this?
I don't know if we do.
I don't
No.
think so. There are a few issues. There's at least one issue for the sound as well. Maybe that's not the optimal. So
We should at least, yeah, we should probably have an issue.
All right, well, I gotta go. Discuss on another meeting that I'm 7 minutes late to.
Okay.
See you all there.
Bye.
Thanks.
Bye.